Hey guys, what's going on? So today we're going to be going over special right triangles. So there's two main types of special triangles, and we call them special because they follow a certain ratio uh, along all the sides, where if you're given one side of the triangle, you can actually find out the other two based on those ratios if it's one of the given triangles. So reminder that your smallest side will always be opposite from your smallest angle, and then medium side will be across from medium angle. And of course, your longest side, which in the case specifically for a right triangle, will be your 90 degrees, and it is directly opposite to the hypotenuse. So your shortest side, which is across from 30 degrees, we call S. So your shortest side is S. The side across from 60 degrees, which is your medium side or your longer leg, is that same number S times root 3. Then your hypotenuse is 2 times S. S being whatever number this short leg is. Oop, too far. All right. So we'll do one of these examples. So we'll look at just example one. I want you to find the missing sides x and y. Okay, so first things first on these type of questions, I see and can identify this is a special triangle. It's a 30, 60, 90 degree triangle. So it might be helpful to draw my table, 30, 60, 90 degree triangle. I know those ratio of sides are S times root 3, and 2 times S. And then write down your given, the side they give me, 5 is across from my 30 degree side, so that's S. Okay. So then to get my other sides, well, my medium side is just S times root 3. Well, S is 5, so that's just 5 times root 3. And my longest side is just 2 times S. S was 5, so that's just 10. So X specifically was the one across from 60, so that's our 5 root 3. And Y was our 10. Okay. Going on to another example. Quick reminder, an algebra reminder on rationalizing the denominator. So when we have a radical in the denominator, we want to get rid of it because some old Greek guys said so, essentially. This stemmed from the fact about when there were, before a time when there were calculators, specifically in Greece, especially, they did not like radicals or fractions or anything like that in the denominator because dividing by anything that wasn't a whole number was just essentially a little hard to wrap your head around. So it was just easier to always get rid of anything in the denominator that wasn't just a whole number. And for some reason, we just still do it, even though we have calculators. But still important concept. So if I want to get rid of this radical, okay, I just multiply the top and bottom by root 5. 5 times root 5 is just 5 root 5. Root 5 times root 5 is 5. 5 divided by 5 is just 1. So this simplifies to just root 5. So if you get a calculator, okay, and you put 5 divided by root 5 and hit enter, okay, you get some decimal. If you were to type in root 5, hit enter, you get some decimal. And it's the same exact decimal. These guys are the exact same number, okay? The reason why these guys are the exact same number is because when we multiplied by root 5 over root 5, okay, well, root 5 over root 5 is just 1. Anything divided by itself is just 1. So essentially, we just multiplied this thing by 1, just in a clever way to get rid of this radical in the denominator, and we're left with this. But they are the same value. Okay, so every time you're rationalizing something, it has the same value. So also, if you wanted to double check that you did it right, you just take your original one and plug it in the calculator, take your new one, and make sure they are the exact same number. Okay, and we're going to need to know how to do that for ones like what we have here. Let's just look at example 4. Again, we have a 30, 60, 90-degree triangle. Okay, we got two missing sides, x and y, and they give us the side across from 60. But let's write down our chart. So we already know this is a 30, 60, 90-degree triangle. They have a ratio of s root 3, and 2s. Okay, they give me the side across from 60, my medium side, which is 12. So I need to find the other sides. Well, imagine an equal sign here. They already told me that essentially that s root 3 equals 12. So why don't I solve for s? So s equals 12 over root 3. Hey, there's why we practice that. Let's go ahead and rationalize the denominator. Okay, so times root 3 over root 3 equals 12 root 3 over 3. 12 divided by 3 is 4, so 4 root 3 is my s. And my longest side across from 90 degrees, so the side across from 30 is y, so y is 4 root 3. Okay, so my long side is just 2s, so 2 times 4 root 3 is just 8 root 3. Okay, when you're multiplying something like 4 root 3 by a whole number like 2, you just multiply the coefficient in front of the radical by 2. Okay, so that's 30, 60, 90. On to the next type of special triangles, we have a 45, 45, 90-degree triangle. This one stems from when you cut square into two equal triangles, okay? So cutting 90 degrees in half here is 45 degrees. Cutting 90 degrees in half here, again, it's 45 degrees. So this one's a little bit easier because you cut a square into two equal triangles. Well, guess what? It started off as a square, so these two legs are still the same. They're still congruent to one another, okay? And then your hypotenuse, the side across from 90 degrees, is just whatever that number is. So these are s. So this is just s times the square root of 2. And that's it. So this one's easier because your legs are always the same thing. So really, you only have to calculate one number, all right? Because if they give you one of the sides across from 45, you automatically know what that one is. So you really only have to calculate this thing. And vice versa, if they give you this thing, you really only got to find s, and both of them are s. So you only have to do it once. So these are a little bit easier, in my opinion, at least. Let's just look at an example real quick. Okay, the side. So first of all, we can still do the chart. It's nice to identify this is a 45, 45, 90-degree triangle. I know this is s, s, s times root 2. And they give me a side across from 45 degrees as 8. So I got to find the others. So guess what? The other side across from 45 degrees is also 8. And then the side across from 90 degrees, my biggest side, is s times root 2. S is 8, so it's just 8 root 2. That's it. Okay, and that is it, guys. Thank you.